All right, so I think we got to exercise 10 last time. So we'll start on exercise 11. And so here we have 8z plus 40 divided by z divided by z plus 5 over z again. All right. So first of all, if I gave this problem on a test or a quiz or something, it wouldn't look like this. Like anytime if I was to state this problem on your test or quiz, it looks like the following. I write it as a compound fraction. I would write something like 8z plus 40 divided by z divided by z plus 5 over z. So like that's the notation I would use on a test or quiz. So we'll start with that. So how do we simplify that? So let me remind you the rule. It's like the basic pattern is this: if we have a over b divided by c over d, what's that equal to? It's equal to a times d over b times c. Right? So following that pattern, I get 8z plus 40 times z divided by z plus 5 times z. So the way I think about that, guys, is I think about this z sort of going down here, and I think about that z going up there. That's how I mechanically think about it. Of course, like this z essentially, in other words, this z is that z, and that z is that one. Anyway, so then what? Well, then we can cancel the z's, right? At z over z, that just cancels out. And what else can we do? Can you factor an 8 out of the numerator? I can factor an 8 out. I've got 8 times z plus what? Yeah, 5. Oh, but look at then. Then we have z plus 5 over z plus 5, right? So we can cancel those out. And we're left with 8. I don't know about you, but when I look at this to start with, it's not apparent to me that that's equal to 8 for most values of z. Now, the truth of the matter is, there's some fine print we're omitting here, all right? Like, when we do symbolic calculations like this, it's good every so often to take a second to be more honest. And if I was more honest here, I would say that this calculation holds for what? Calculation true as long as z is not equal to, well, z can't be equal to 0, or also what else, or rather, and what else has to be true? Z not equal to what? Z equal to 0 gets into trouble because we'd have division by 0, right? What other value for z shouldn't we allow in this calculation? So this is kind of, the question I'm asking right now is in the same spirit as like the first 3 exercises on this exercise sheet, right? Like what was the domain of the function, or what b we're not allowed for exercise 1 for that rational expression to make sense, right? We looked to avoid division by 0, right? So here, obviously z equal to 0 gives us division by 0 for each one of these fractions, right? But since z plus 5 is in the denominator of the overall fraction, we also must avoid z equal to minus 5, okay? So anyway, that wasn't asked for in exercise 11, but you know, I think it's worth taking a second to talk about. And so I'm just sort of apologizing to you that I could make these kind of like, hey, this only makes sense for these values comments in every one of the examples we do, but a lot of times I'm not doing that, so we can just focus more on the algebra steps, okay? All right, so exercise 12. We have y squared minus 4 divided by y squared minus 12y plus 36. And I'm just going to go ahead and write it like I would on the test. Divided by 9y minus 18 divided by y squared minus 5y minus 6. All right? So I guess my first step would be to just make it as a single fraction, you know? This is y squared minus 4 times y squared minus 5y minus 6 divided by 9y minus 18 times y squared minus 12y plus 36. So, I think we could factor a 9 out of the first one here, right? See that? There's like a 9 we could factor out of this guy. We do there's an awful lot of factoring we can do, right? So like upstairs, I've got y minus 2 times y plus 2. And I got a 9 times y minus 2 downstairs. Let's see here. That y squared minus 5y minus 6, I can factor as what? I think that's y minus 6 times y plus 1. Because when I multiply out what I just wrote in red, we get a minus 6 plus 1, which would give me minus 5, and minus 6 times 1 is minus 6, and so I think that's good. This guy, y squared minus 12y plus 36, is y minus 6 times y minus 6, I believe, right? So it looks like we got a bunch of cancellations again, right? What cancels here? Yeah, the y minus 2. Thanks, Monica. And y minus 6, yeah. Anything else? Nope, I think that's it. So the answer will be y plus 2 divided by 9 times y minus 6. All right. Let's continue. Oh, yeah, what happened to the y plus 1? That's a good question. Thank you, Tate. It's still in the marker? Um, just trying to see if you guys are paying attention. So yeah, there should be y plus 1 there. There. Go grab my eraser. I'll be back a second here. So I suppose I should mention again, these problems we're working through, they're all taken from your my math lab problems, right? So these, I'm actually helping you do your homework at the moment. But I hope more than that, this helps you understand the material. All right, let's see here, exercise 13. Here we have w minus 4 over w plus 1 plus w plus 5 over w minus 2. We're supposed to add and simplify, all right? So this kind of problem, the way I think about this is I think, okay, so what I've really got is w minus 4 times w minus 2 over w plus 1 times w minus 2 plus w plus 5 w minus 2 So what I do is I think about multiplying each one of the fractions by 1. And I do that in such a way so that they have a common denominator, right? Because then, like, w plus 1 times w minus 2 is equal to w minus 2 times w plus 1, right? And once we have a common denominator, then we can add things, right? That's the key idea here. It's just like if you have a third plus 2/3, well, then you can say, oh, well, that's 3 over 3, right? That's 1 plus 2 over 3. It's 3 over 3, right? But if I have a third plus 2/5, then I can't just add them because they don't have the same denominator, right? So to add them, I have to do some kind of trick. I do 1/3 times 5 over 5 plus 2/5 times 3 over 3, and that gives me, 5 plus 6 over 15. It gives me 11/15. So to add fractions, we do this trick. We multiply each of the fractions so that they have a common denominator. All right, if the fractions don't have the same denominator to start with, then we modify them so that we can add them. That's the underlying principle here. So that's what I did. I multiplied by 1 in such a way that we can add them. But now let's do it. All right. So this is equal to w minus 4 times w minus 2 plus w plus 5 times w plus 1, all divided by w plus 1 times w minus 2. All right? And if we're going to simplify, probably should multiply those out and see if we can eliminate any kind of terms, you know? Because usually, oftentimes what happens is there might be some cancellations or something, especially if it's a minus instead of a plus. This one happens to be addition, but so I've got w squared minus 4w minus 2w plus 8 plus w squared plus w plus 5w plus 5 and, well, we get 2w squared, right? How many w's overall do we have? I've got minus 6 here. I've got plus 6 over here. Hey, I've got 0 w's, right? So the w's all cancel out, and I'm just left with 2w squared plus what? Plus 13 divided by, you could either leave it like that, or you could multiply it out. I mean, I'll multiply it out just for fun. W squared minus w minus 2, you know? So there you go. Listen, in this kind of problem, if I said add the rational functions and simplify, what I boxed could be the answer, right? But, you know, or 2w squared plus 13 over w plus 1 times w minus 2, that would also be like a completely legitimate answer. I could go with either one of those. And, you know, like I've told you guys, simplification, you know, beauty is in the eye of the beholder. You know, different people might think one is better than the other. Let's move on to exercise 14. See here, exercise 14, it's again, we're adding two fractions, right? And let's see here, we've got w. If you don't mind, I'm going to take exercise 14 and rewrite it in terms of x. So I've got x over x squared minus 2x minus 3 plus 2 over x plus 1. All right. Now, let's see here. Let me make a side comment. Notice x squared minus 2x minus 3 is equal to what? X minus 3 times x plus 1, right? So that means that there's a hidden x plus 1 in the first fraction, right? So the smart thing to do here is don't change the first fraction at all. So let me give you a numerical analog to this. Suppose you were doing something like adding 1/10 plus 3/5, right? If you're faced with this kind of situation, you don't change the 10th at all, right? You just convert the 5th to a 10th. That's the way I would do it anyway. I would say if that's really 1/10 plus 3 times 2 over 10, right? Because it's 6/10. In other words, I multiply by 2 over 2 here, really, right? And in the same way, This one, I'm going to leave the first thing alone because it's already got the x plus 1 factor in it. The second one, though, is missing the x minus 3. So the wise way to do this one, I think, is x squared minus 2x minus 3. Leave that alone. Leave this alone, too. But then multiply that by an appropriate version of 1. In this case, the one I want is x minus 3 over x minus 3. Right? Of course, this down here works out to 7 tenths, right? But anyway, not really the point, but anyway, just in case it was bothering you. So I've got x plus 2 times x minus 3 divided by, well, x squared minus 2x minus 3. And can we simplify that at all? Maybe? Looks like I've got 3x minus 6, right? Over x squared minus 2x minus 3. Maybe, I don't know, can we factor anything out? I don't know, maybe. I think I'm going to go back to factored form just to see, just to make sure nothing cancels out, right? So that's 3 times x minus 2 over x minus 3 times x plus 1. Okay, fair enough. That's as simple as we can get. So some people might argue that the expression right above it is the simplified answer. I'd say either one of these, completely fine answers for this problem, okay? Any questions? All right. Now, so you notice in this last one, I did not just blindly follow. I introduced a principle, like an algebra principle last class, that was essentially this, right? I said, if we have a over b plus c over d, we can add those fractions as ad plus bc over bd, right? Can you guys tell me why I didn't follow that pattern for this example? I mean, if I had done that, then that would have given us a denominator which was third order, right? And you could have done that, but it would just have made the algebra more difficult because we would have had like a third order denominator, and the numerators would have been like quadratic in such a way that we would have to see how things cancel out. Like it would have made the problem harder to work it that way. I could work it that way if you'd like to see it, but I've been advised not to work problems more than one way, so I will go on. Exercise 14. This was exercise what? This was exercise 14, actually. I changed the W to an X. Exercise 15. Here we have x minus 7 over x minus 8 plus, minus rather, x plus 1 over x plus 8 plus x minus 24 over x squared minus 64. So what do you guys think about this one? See, what we're looking for is a common denominator. Can you guys tell me what the common denominator should be here? I'll give you a hint. 8, well, no. X squared minus 64 is x minus 8 times x plus 8, right? That's a helpful hint. Just to kind of give you a numerical analogy to this, this would be something like 3/7 plus 2/8 minus 1 over 56. That would be maybe a numerical analogy to this. See, these two, 7 times 8, gives me that 56, right? Just like this times that gives me that. My point to you is that there's already an x minus 8, and there's already an x plus 8 in the third fraction, right? In other words, I could ask the question, what's the least common multiple? Least common multiple of x minus 8, x plus 8, and x squared minus 64. The answer to that question is x squared minus 64. X squared minus 64 is the least common multiple. Anything's a multiple of itself, and if we multiply x minus 8 times x plus 8, we get x squared minus 64. So what I suggest, the way to do this problem is to multiply the first one by x plus 8 over x plus 8. And then we subtract x plus 1 over x plus 8. I'll let you guys fill in the blank here. So what should go in that blank? Can you guys tell me? How can we make that middle fraction also have a denominator of x squared minus 64? What do you think, Monica? You have a guess? No guess? Olivia, guess? It goes in the blank here. Right, so we want x minus 8 over x minus 8 because we can always multiply any fraction by 1, right? And that one, see what that does is it makes this and this and this all the same. Now they have a common denominator and we can add. So we have to make a common denominator before we add. And so we've got x minus 7 times x plus 8 minus x plus 1 times x minus 8 plus x minus 24. All right, so what is that? That's x squared. Minus 7 plus 8 is plus x minus 56. Parentheses are your friend here, so put parentheses around this middle term. Minus x squared, that's a plus x, but minus 8, so minus 7x minus 8. Now we should, try to cancel out things if we can. The x squareds cancel, right? And we've got an x, and then minus a minus gives me plus, so plus 7. 1 plus 7 plus 1 is 9x. 9x's. Minus 56. plus 8. Let's see here. Minus 56 minus 24 is minus 60 minus 80. Minus 80 plus 8 is minus 72. Ooh, I think there's going to be more cancellation here. See, that's... I think we should go back and I mean, we could end here, but that wouldn't be best, right? We could do better. I'm pretty sure we can cancel more out here. I'll factor the 9 out, right? 9 times x minus 8, right? And downstairs we got what? X minus 8 times x plus 8, right? So what cancels? X minus 8, right? And we're left with an answer of 9 over x plus 8. I think if you can do this problem confidently without help from a tutor, you know, like if you can just put this in front of yourself, put away your notes, work it out, and get to the answer here, you pretty well understand this material. This is a pretty hard problem for us here. So, I mean, it's got 3 fractions instead of 2. That sort of compounds the confusion, right? If you're a little bit lost. All right. Continuing. That brings us to, oh, hey, this one's easier. This one's got 3 things in it, but this one's actually pretty easy. So the reason this is easier is because it goes the other way. We've already got a common denominator. In this case, 8a to the 6th minus 6a to the 4th plus 18a squared. And that's all divided by 2a squared, right? And we're asked to simplify. You know, there's a fundamental asymmetry here, right? That you should keep in mind always. And the asymmetry is this. If we have a plus b plus c over d, well, that's a piece of cake. That's just a over d plus b over d plus c over d. In contrast, d over a plus b plus c is not equal to anything nice. All right? And I understand, you know, why students make the mistake they do, because we get, you know, you learn the one step, right? And then you confuse in your mind that they're the same, and you make kind of the analogous but wrong step for when the addition's down here. But you just can't do it, all right? Like it's not d over a plus d over b plus d over c or anything like that. All right? So that's just a caution. But this one we can do what? We have a common denominator, 2a squared, so I've crowded myself, I'll put it over here. So I've got 8a to the 6th over 2a squared minus 6a to the 4th over 2a squared plus 18a squared over 2a squared. How can we can simplify those further, right? We've got what? 4 a to the what? What's a to the 6th over a to the 2? So we can think of a to the 6th over a to the 2 as a to the 6 minus 2, right? That's a to the 4th power. So we have 4a to the 4th for that first term. What's 6 over 2? Well, it's 3, right? So minus 3, and what have we got there? A to the 4th over a to the 2nd, which is what? A to the 2nd again. And then what's 18 over 2? it's 9, right? So 9, and the a squareds cancel, right? So we're just left with a 1 there from the a's. So there you have it. So I think this problem looks scarier than it actually is, right? On first glance, it looks kind of intimidating, but it's actually not bad at all. Example 17, or exercise 17. Back to division again. That's right. So I have 3b squared plus 3b minus 8 divided by b minus 2. Can we do anything there? Let me try. I'm going to try to factor the top, maybe 3b and b. If we're lucky, that'll factor, maybe. 8 is like, either I can look at 8 as like 1 times 8, or minus 1 times 8, or I could look at like 2 times 4, or minus 2 times 4. I need to somehow get a 3. Do we do long division in here? Polynomial long division? Curses. Guess that's just the next course. It would sure be handy to have here. Man, we should do that in here. Oh well.
Don't you just, like, put the top equation, like, in the division thing, and then put b minus 2, like, on the outside? Isn't that how you do it?
Put b minus 2 on the outside.
So you do the little division.
Oh, yeah, I mean, I've already changed the little division thing to this.
Yeah.
You think that's it?
I'm talking about, like, the long division.
Oh, how to do the long division? But I'm not supposed to do it in here, am I? But hey, wait a minute. I'm the instructor. I can do it if I want, right? This is not required. But so I'll just remind you. If we have 137 and we divide it by 8, remember how that goes? You go like, well, 8 doesn't go into 1, but it goes into 13 one time, right? So I put an 8 down here. I subtract. I get 57. I go, oh, wait a minute. So 7 times. So I put a 7 here because 7 times 8 is 56. And then I get a 1. At that point, that's the remainder. But that tells me that, 137 over 8 is equal to 17 plus 1 over 8, right? Like, that's the meaning of long division. Well, you can do the same thing with polynomials. In particular, I could do this trick. I could do 3b squared plus 3b minus 8, and I could divide b minus 2 into it. And so the way that would work is I'd put a 3b here, because in order to get 3b squared, I'd have to multiply this by 3b. So that gives me 3b squared minus 6b. And then I'd subtract, and that would give me 9b minus 8. And, so that would be 3b plus 9. And that would give me 9b minus 18, which would give me a remainder of 10, which tells me actually that this is this is it. This is as far as it goes. Like, you cannot factor b minus 2 out of that. We cannot factor b minus 2 out of this. Like, I was hoping what was going to happen was that this was going to be b minus 2, and then we'd have b plus whatever here, and then we could cancel, and we'd be, oh, it's 3b plus whatever. But it just isn't the case. So this homework problem apparently just wants you to divide, like, I'm sorry, I don't even know how to explain it. 3b squared plus 3b. The homework problem is stated like this, divided by b minus 2. And I think maybe it just wants that as the answer. It is exceedingly silly. So let me suggest that exercise 17 is stupid. Okay? You can ignore exercise 17 if you wish. Let's move on to exercise 18, since I think it has something more intelligible to say. We did have the factor theorem, didn't we? Did we talk about factor theorem? Nope, that's the other class, isn't it? Oh, I'm so sorry. Well, I'll just say it this way. There are still other things to learn about factoring polynomials, and in like the pre-calculus class, we do share some additional tips and tricks with you there. The unfortunate thing is, for me, as an instructor, sometimes, if I'm not careful, I start thinking about those things in here, which, of course, would not be helpful to you since we don't know those things. All right. Exercise 18, 9a squared minus b squared divided by ab all over 3a minus b over b. All right. And then exercise 20 was x squared minus x minus 30 divided by x squared minus 3x minus 40, all divided by x squared plus 7x plus 10 divided by x squared minus 2x minus 8. All right, so chew on these here for a minute. It is unfortunate we don't talk about long division in here. It does give added insight to factoring. I'm not sure how the curriculum has gotten structured the way it is, but I just kind of followed the, setup as it was given to me. I mean, it's implicit within your book. I've just pretty much gone with whatever the book gave us as a problem. I've worked those, so I didn't think to ask the more rebellious question of, how is the book wrong? I will always do that in upper level classes. That's like core to my DNA in my teaching, is to assume books are wrong. But it's a principle that served me well. Anyway, so there it is. Like, all I did was do what? I moved the denominator of the numerator downstairs, right? And I moved the denominator of the denominator upstairs. That's the major step. Now we can simplify, right? Can we? Oh, hey, what's 9a squared? Well, these b's cancel, right? We can get rid of that, right? And actually, that's 3a minus b times 3a plus b, isn't it? See, because 9a squared is 3a quantity squared, right? So this is really the difference of squares, which we can rewrite like that. And so these guys cancel. And we're just left with 3a plus b divided by a. Now that's one like totally legitimate answer. Can you tell me another like nice way to simplify this? AKA 3a over a plus b over a, right? Which is equal to what? The a's cancel here, right? And we're left with 3 plus b over a. 3 plus b over a. That's another pretty nice way to simplify this quotient. All right, guys, so help me out. What's the next one here? Can you guys see any factoring? There's got to be a bunch of factoring that goes on here. So I will just go ahead and put I won't factor to start with. I'll just write them out where they belong, and then I'll factor them next. So this is really the same as this, right? So I've traded my compound fraction for a single fraction here. And can you x squared minus x minus 30 is what? That's x minus 6 times x plus 5, right? X squared minus 2x minus 8. 8 is 4 times 2, right? So I think that would be x minus 4 times x plus 2. And 10 is 2 times 5. 2 plus 5 is 7, so this must be x plus 2 times x plus 5. 40 is 5 times 4? No. 40 is what? 40 is 8 times 5, right? That's still wrong. Yeah. No, 8 times 5 is 40, right? Yeah. And 8 minus 5 is 3. Oh, we must meet x minus 8, x plus 5. So I think that'll do it for us. Let me just show you. So this one was this one was from that one. And this was that, and this guy factored as that, and of course this one right here became these two factors right there. All right, now that we've got all that done, what cancels out? A bunch of stuff, right? Oh, here's one. I see x plus 2 here and there. Ooh, I see x plus 5 here and here. I think that's it. So we have x minus 6 times x minus 4 divided by x minus 8 times x plus 5. There we go. Sure. Give me a second here. I want to load up some problems. Because what will happen if I just make them up, they will have answers which are truly horrible. So it's better if I go with the the problems which are from the book, or from my math lab in this case. I'll eventually find what I'm looking for. What on earth? What is the deal? I'm having trouble finding what I wanted in the in my Google Drive, So strange. Oh, Math 101 homework statements. It's hidden in plain sight, So we have now reached section 5.5. All right, I mean, there's one more in the exercise sheet, but I just can't bring myself to do it. I'm bored with these at the moment. I'm going to move on. We can talk about the last problem in the homework in the exercise sheet later if you want. But I'm just going to go ahead and start working on 5.5 with the time that remains, about 15 minutes here today, right? And so section 5.5, basically sections 5.1, 5.2, 5.3, 5.4, they're all about manipulating rational expressions and simplifying them, which is what we've been doing, all right? Section 5.5 takes the next logical step and says, what about rational equations? All right, what about equations that involve rational functions? So problem 1 in section 5.4 is 4/5 plus 2/27 equals r over 45. Is that right? 4/5 plus 2/27 equals r over 45. So you're supposed to find the solutions to this. How should we do that? So what I would do is I would make this into a single fraction. This is 4 times 27 plus 2 times 5 over 5 times 27, right? And that's equal to r over 45. I think that's 108 plus 10. So I think I've got 118 over 135 equals r over 45, if I haven't made a mistake with the arithmetic. How should we solve that? I suggest we just multiply the equation by 45, right? If we multiply by 45, then we've solved for r, right? So multiply by 45. We get 118 over 135 times 45 equals to r. And if we go back to how we constructed that, that's 118 was what? It was, 118 is whatever it is, but that's 118 times 5 times 9 divided by 5 times 27. But what 27 is what? It's 3, well, 27. So the 5s cancel, and 9 over 27 is 3. So I get 118 over 3 equals to r. And I think that's all I can do. Yeah. Of course, you could use you could jump here and just go to the calculator at any point, right? I mean, like you don't have to do this arithmetic by hand if you don't want to, right? Like even the first addition, you could have used your calculator to add and get 118 over 35 or 135, right? Your calculator does do exact fractions, right? Here, let's look at jump ahead here a little bit. Let me look at another one. So problem 4, actually, in your math lab is s plus 11 over s equals to minus 12. I'll write it as x. X plus 11 over x equals to minus 12. So can we solve this kind of equation? How do you solve this kind of equation? I mean, generically speaking, you'd like to isolate x, right? If you can isolate x, then you're good to go. That doesn't look very hopeful here because I've got an x, I've got a 1 over x, right? So if I isolate the x, then the 1 over x is on, the 11 over x is on the other side, right? And if I isolate the 11 over x, then the x is on the other side. So it seems like it's kind of like whack-a-mole, right? Like the x or the 1 over x is one of the others on the other side, right? So how do you do this problem? Let's see here. Can x be, is x equals to 0 a potential solution? It can't be, right? Because that would be division by 0. So we shouldn't really lose anything if we multiply this equation by x. What happens if we multiply the equation by x? We get x times x plus 11 over x equals to minus 12x. What's that give us? X squared, right? Plus 11 equals to minus 12x. That looks hopeful. That's x squared plus 12x plus 11 equal to 0. And that's the kind of equation we have tools in our toolbox to solve, right? Like we know how to solve that. We can try, right? We can complete the square and do that stuff. In this case, I think the easiest way to do it is just a straight up factor, right? This is x plus 1 times x plus 11 equal to 0. So what are the solutions? X equals to minus 1 and x equals to minus 11 solutions. Now, in this kind of problem, whenever you do something like multiply by x, you got to ask yourself the question, like, did I change the equation or something? So to be sure, to double check our work, we really should go back to the original problem and try plugging in the numbers and see if it actually works. All right, just to be doubly sure about the solution. So you can check, right? Minus 1 plus 11 over minus 1 equal to what? Minus 1 minus 11, right? Which is minus 12. We're good. How about the minus 11? So minus 11 plus 11 over minus 11 is equal to minus 11 minus 1, which is also equal to minus 12. Check. Now, in my heart, I knew that we weren't going to have a problem because the only thing we did was multiply by x, right? And the only place where that's not legitimate is when x is equal to 0, but I already knew 0 wasn't the solution. So like the fact that we found 2 solutions, I didn't really see the need for checking here, but